In this video, I'm going to show you how to do problems 10 and 11 from week 15 homework assignments. And these two questions come from section 12.12. And 12.12, we are talking about a two-way analysis of variance. We have two cases to do the testing for the hypothesis regarding the interaction effects and hypothesis regarding the main effects. Now, we can use the TI 84, 83 to do the analysis, but it is difficult because you have to download the program from the website into your TI 84 or 83 before you can apply the tools that do this analysis. Now, because of that, I don't recommend using the TI 84 or 83 in this case. And you can use the Excel spreadsheet to help you to do these two questions. So let's do that using the Excels in this problem. And the T here indicating that I can use the technology. Okay, so we have the problem that the accompanying data table lists the measurements of the self-esteem from a student project. The objective of the project was to study how levels of self-esteem in the subjects relate to their perception of self-esteem in all the target people who were described in writing. The test here works well even though the data are at the ordinal level of measurements. Now use alpha equals 0.05, a significant level, and apply the methods of two-way analysis of variance. What is your conclusion? So first thing, it states the null and alternative hypothesis in the test for the effect of the interaction between the row and the column factors. Now, for the null hypothesis, we always make the assumption that there is no interaction between the subject's self-esteem and the target's self-esteem in determining the self-esteem measures. And for the alternative hypothesis, we always indicate that there is an interaction between the factors. Okay, so for the null hypothesis, it's always no interaction. For the alternative hypothesis, there is an interaction. Now, how do we find the F statistic for this question? Now, if you click on the table, you get this table. This one has the two factors for the row, low and high, and three factors for the columns, low, medium, and high. Now, if you open that on the Excel, because we are doing this on the Excel analysis. Okay, open that. You will see that it does not have a correct display of the data as we saw from the table, right? The table right here. So we cannot use the table from the Excel. We have to enter them manually from our own Excel spreadsheet. Now let's do that. Okay, we have the low, right? The low case, and then we have the low for the low for the column, low, medium, and high. Medium and high. Okay. Now for the low, let's start from the low first. We have 5, right? 5, start from here. 5, 4, 5, 4, 3, 4. And then we have more here. So keep going. 4, 5, 3, 4, 5, 4. So that is the low. Now for low and medium, we have the two middle columns. Let's enter them. 3, 2, 3, 3, 3, 2, and then next one 4, 4, 2, 4, 2, 3. Okay, and then the height is a lot, 2 columns. All right, let's do that. We have 2, 3, 2, 3, 3, 3, and in the last column we have 2, 2, 4, 3, 2, 2. Okay, so this is done for the low. Now for the high, we stack from here, and then For the high as well, for the low, we also have low, medium, and high. For the low, we have the 2 columns here, so I'm going to input them all here. 2, 4, 2, 2, 2, 2. And then the next column, 2, 2, 3, 4, 2, 3. Okay, for medium, we start from here. 4, 1, 1, 2, 3, 1. And then the next one, 3, 2, 3, 4, 1, 4. And then we have 3. Sorry, it should be 3, 3, 3, 3, 4, 3. And then the last column, 2, 2, 4, 4, 3, and 4. Okay, so now we are ready to do the analysis. Okay, make sure you go to data. Data right here. So if you don't see the data analysis tool here, you have to go to file, again options, click on add-ins and analysis toolbar, and then click on go Excel add-ins, click on go. That will add that to your Excels, but I already have it, so I don't have to redo it. Now we can do the analysis now. Data analysis. We are using the ANOVA 2-factor with replications because we have repeated column and row. So you have to use the one with replications. Okay, click OK. Now let's clear everything. Okay, the input range should be everything. So I highlight everything. Okay, that is the input range. The row sample, okay, we have how many row sample? Okay, for the high, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 rows for the high and 12 rows for the low. So that should be 12. The alpha is 0.05. The alpha is 0.05. And we can check that. We have the problem with 0.05 here, so that's good. You can keep that as 0.05, and then finally you can display the output range. So for the output, sorry, not yet. For the output range, you can place the cursor anywhere on the right side as long as you have the spaces. So let's just place them maybe here. Okay, random place on the right side of the data. Click OK. Okay, where did I do wrong? They said that we have 12. Okay, let's check it again. Make sure we have the same rows per sample. Okay, let's cancel it. Check it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 row for the low. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, for the high, oh, I have the one extra 4 here, that's why. Okay, that's why 4, 3, 4. Okay, hold on, we may have entered some wrong information here. Okay, let's check again the high part here. Okay, we have 3. Okay, start from. Yes, I think I input some wrong info here. Okay, so we stack the high from 3. It's supposed to be 3. So let's clear this column again. Okay, so we stack from 3, 3, 3, 3, 3, 4, 3, and then 2, 2, 4, 4, 3, 4. Okay, that should be correct now. Okay, let's do the data analysis. Okay, the input, let me do that again. Highlight all of them, and then click OK. Now you have the analysis. We are looking for ANOVA only, so you can just ignore the other statistic here. This is the median and the mean. You don't need to worry about that. So we are looking for the ANOVA only, and you are looking for the problem is asking you for let's clear that. We are looking for the value of the test statistic for this test for the interaction between the row and column factors. So because we are looking for the interaction, which is the third row, and the test statistic, the F test statistic right here, 10.64, we can route to 65. So 10.65 is the answer. So 10.65, and then check the answer. Nice. Let's move on. What is the corresponding p-value of the test statistic? Okay, we have the interactions. The p-value of that is right here, 9.85, 10 to the minus 5. Right, this is 9.85 times 10 to the minus 5. So let's input it here. Okay. Okay, route to 3 decimal places. This is 9.85, like 10 to the minus 5. So that should be 0.0000981. Let me check. 1, 2, 3, 4, 5. Okay, this is in decimal, right? This is 9.81 times 10 to the minus 5. Right, but you want to route it to 3 decimal places. 3 decimal places. Then you just erase the last few digits, and it's around 0. Okay, because it's very small. Okay, so we can state the conclusion. Now, if the p-value is larger than the alpha, we do not reject the null hypothesis. In this case, the p-value is 0.000981, which is very close to 0, and this is less than the alpha significant level. Then we reject the null hypothesis. So we reject this statement. Okay, so we reject the H0. There is sufficient evidence to warrant rejection of the claim that the measurements of the cell team are not affected by an interaction between the subject cell team and the target cell team. Okay, so there does appear to be an effect from interaction between them. Okay, because if we reject this, that means there should be an interaction between them. Okay, that's good. Now let's move on. State the null and alternative hypothesis in the test for the effect from the row. Now in this case, the test for the effect from a row factor should not be done, because we found earlier that there is enough evidence to see the interaction between the row and the columns. So you don't need to, you should not have done the testing for the row factors. Now, what is the value of the test statistic for this test? So go back to the Excel. We are looking for the row or the sample, right? The sample, this is the row, and we're looking for the F statistic. This is 7.0, route 2 to 3, so 7.03. 7.03. That's true. Okay, let's see. No, you don't do that, because why? If you just look directly here and you enter the absence statistic, that should be wrong, because we already answer in this case the test for the effect from the row factor should not be done. So this is a tricky question. Do not put in the absence statistic if you had this option. So in this case, we don't have the testing. Okay, so I just put it here so that you can see that this is a tricky question. So check the answer. Nice work. And then what is the corresponding p-value for the test statistic? Again, we don't do the test, so just move on. Now states the conclusion here. Again, we don't do any testing, so we don't do any conclusion here. And then the same thing to the column factor, right? The column factor is the one on the columns low, medium, and high. Because we again, we had the interaction between the row and columns. We have the we had the interactions. Therefore, we should not doing any testing for the row and column. So in this case, we don't do any testing. Okay, move on. And then we don't do any testing. We don't have any value. And just keep moving on. And then keep moving on. And the next question. Okay, so that is all. Alright, next question is question 15, question 11. So in this question, let's move on with the same type question 12.12, two-way analysis. So again, we have the table list the post rate. 0.05 is alpha, significant level. Okay, so let's click on that. Okay, we have the again, two factors in this Excel. So let me go to another sheet here. Okay, I have let's enter the data, female, and then I have one column is under 30 years of age, and then the other column is over 30 years of age. Alright, so now let's do the female. Enter our data. Female, I have 78, 105, 80, 63, 61, 98, 83, 98, 99, 89, 95. Okay, and now I have male. Male, I have 60, 81, 57, 67, 69, 73, 74, and then 67, 61, 56. Okay, that is for the under 30. Now we have over 30. Again, we have female. We have the first row data. So 75, 76, 71, 67, 72, 79, 61, 72, 74, 56. And then we have the male 46, 69, 61, 66, 91, 80, 59, 57, 64, 59. Okay, make sure you put the male right in the line that we stack to have the data of the male. Okay, so below this row are all the data for the male. Okay, so now we are ready to do the analysis here. So states of null and on alternative hypothesis for the effect of the interaction between the row and columns. So for the null hypothesis, we always say no. For the alternative hypothesis, yes, there is an interaction. And then next one is we do the analysis. So click on data analysis, two-factor with replication, click OK, and then clear everything. And then I have the whole thing. How many rows? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows for each sample. Alpha is still 0.05, I believe. Yes. And the output range, let's just click on anywhere around here for the output range. Let's put here and click OK. Yes, we have the data here. So we are looking for the interaction, the F statistic right here, 3.60 rounded to 2 decimal places, so 3.62. Okay, 3.62. And then p-value of interaction is 0.065. 3 decimal places, 0.065. Okay, 0.065. Now, if the p-value is bigger than the alpha, we do not reject. 0.065 is bigger than 0.005. Therefore, we fail to reject. We do not reject. We fail to reject the null hypothesis because there is not sufficient evidence to conclusion, and this one means there's no interactions. So there does not appear to be an effect from the interaction between the gender and the age. Okay, next one states the null and hypothesis in the test for the effect from the row factor. So now, because there's no interaction between them, we can go ahead and perform more hypothesis for the row factor. For the row, we have male and female only, right? So first thing is, for the null hypothesis, we always want that they have the same mean. And then for the alternative hypothesis, at least one of them is different from the other for the mean. Okay, so check the answer and then move on. And for the F statistic, in this case, so the row is the sample, right? The sample, and the F statistic 11.23 rounded. 11.23, and then p-value 0.002 rounded. Okay, 0.002, 3 decimal places. Okay, so this one is less than the alpha. Okay, so less than the alpha, that means we reject the null hypothesis. So the only cases that we do not reject the null hypothesis is when the p-value is bigger than alpha. But in this case, less than, so we reject. So we reject the null hypothesis. So either this one or this one. But which one is correct? Because we reject because there is sufficient evidence to warrant rejection of the claim that they have the same mean. We are talking about the mean, not standard deviation. So this is part D is correct. Okay. Now we also do the testing for the hypothesis on the effect of the column. The column we have here is under 30 years of age and over 30 years of age. So again, we want the null hypothesis to be the same mean. The column confirms the same mean, and at least one of them has a different mean. This is the alternative hypothesis. So this is the null and hypothesis, the null and the alternative hypothesis. Now the next one, we are looking for the test statistic. Again, we are looking for the column, so we go with the column. The test statistic of the F is right here, 5.16. 5.16. And then the p-value is right here, 0.029. Okay, 0.029. Check the answer. 0.029, 0.029, and the alpha is 0.05. Okay, so 0.029, this is less than the alpha. So the only way that we do not reject the null hypothesis is when p-value is bigger than the alpha. If it's bigger than the alpha, we do not reject. In this case, it's less than the alpha. Then we have to reject the null hypothesis. Reject, so either A or D. But we are talking about the same mean, so we have to choose D, because A is about the standard deviation. So reject the null. Less than alpha, reject it. Check the answer. And that is the end for this question 11 and 12. So we are using the Excel in this chapter sections because it's more easier for you to use Excel comparing than the TI-84 or 83, which you have to download the program on the website, and it has more complicated procedures that you have to follow. So I decided to show you how to use Excel for these questions. Alright, thanks for watching.